Hi everyone, welcome back to Geeks for Geeks practice and welcome back to another problem of the day. Please give me a quick +1 in the chat if my voice is clearly audible to everyone, and make sure to hit the like button as well if everything is working fine. And then within 30 seconds, I'll be starting with the problem as well. Hi Naikaj and hi Rishit as always. So guys, please hit the like button if everyone can hear me clearly. And then I'll start off with this problem as well. Today's problem is really interesting and also it's quite easy as well. Okay, so let's share the screen and start with the problem discussion as well. So the problem that we are going to discuss is nothing but select nodes. Okay, hi Joel as well. So great. So the problem that we are going to discuss is named as select nodes. Previously, this problem has been asked in a company that is nothing but Flipkart. Okay. So previously, this problem has been asked in Flipkart. Now, what does this problem say? This problem says that you will be given a tree. Okay. You will be given a tree that will have n nodes inside it. Okay. So basically, this tree will be in form of edges. So you will be given edges, and basically those edges, when you combine them overall, so they will be forming a tree. What you need to do is you need to find the minimum number of nodes. Okay, you need to find the minimum number of nodes that you select to light up all the edges of the tree, right? An edge gets lightened up when at least one of the nodes is selected. Okay, what does this mean? So let us say that if we have this edge, okay, if we have this edge, if you have to light up, okay, if you have to light up a particular edge, so in that case what you should do, if you have to light up a particular edge, then you can choose either this node or this node, or you can choose both also. But if you have to light up a particular edge, let's say this is an edge. Now if you have to light up this, right, so in that case either you have to choose this node, okay, or you can choose this node. Is that clear? If you have to light up this edge between these two nodes, so either you can do what, either you can choose any of the nodes, you can choose both of the nodes as well, okay, or you can choose any of the nodes, like either this node or this node, and then a particular edge will get lightened up. Is that clear? Please give me a +1 if this point is clear. For lighting up, okay, basically for lighting up a particular edge, you can either choose this node or this node, any node. Please give me a +1 if that is clear, right? If this is node, if this is a node and this is another node, and we are having this edge, so for lighting up this particular edge, either we can choose this node or this node. Okay, Rishid is clear. What about other people? If others are also clear, so please make sure to hit the like button, because I can see a lot of people are watching us, so the number of likes is less compared to the number of views. So please make sure to hit the like button, guys, if you haven't already till now. All right. Now, in this particular problem, that is what we have to do. So basically, we have to find the minimum number of nodes. Okay. So we have to do what? Please write all in the chat. Now, in this problem, what we have to do is we have to light up. In this problem, basically, we have to light up all the edges, right? Light up all the edges, right? All the edges of the tree, right? So you have to light up all the edges of the tree. And how will you light up? Basically by choosing certain nodes, right? So what you have to do is you have to choose the minimum number of nodes, right? In this tree, in the given tree, you have to choose the minimum number of nodes, right? Minimum number of nodes to light up to light up to light up all the edges. Is that clear to everyone? Is that clear? Please give me a +1 if this is clear. So basically, if you have this edge, right, so you can choose at least one node of these two edges, okay, either this or this, and then this edge will get lightened up. So basically, when you will be having a overall tree structure, so in that case you have to tell that, okay, what is the minimum number of moves that you will be having, what is the minimum number of nodes that you will be choosing, right, such that all the edges of the tree get lightened up. Is that clear? Please give me a +1 and then I'll proceed further. Is the problem statement clear? Because once the problem statement is clear, then everything else is quite easy for us, and it's not a hard problem. I will say it's a medium level problem only. So till now everyone is clear. If you are clear, you can hit the like button and you can give me a +1. I'm just waiting for your responses. If you have to light up a particular edge, then either you can choose this node or this node, or you can choose both also, right? Now if you have to light up all the edges of the tree, so in that case you have to tell that, okay, what is the minimum number of nodes that you will be choosing. Okay, Rishit says clear. I hope that others are also clear with this idea. Now in this case, let's say if we have been given this particular tree, so one is connected to two, one is connected to three as well. So let's quickly draw this tree so that we are more clear with the sample. So let's say we have this node 1. Now 1 is connected to 2, let's say, and 1 is connected to 3 as well, right? Now after 1 is connected to 2 and 3, then 2 is connected to 4, and then you can say that, let's say 2 is connected to 4 and 3 is connected to 5 and 6. So let's say 3 is connected to 5 and 3 is connected to 6 as well. Okay. Okay, I haven't been able to solve today's problem. No worries. We will be solving that together. Okay. I can see a lot of people are watching us. So please hit the like button, guys. If you have hit the like button, you can give me a +1. Okay. I can see a lot of people are watching us. So if you have understood till now, so you can hit the like button. Okay. Now the target is that you should light up all the edges. Like you have to light up this edge, you have to light up this edge, this edge, this edge, this edge. So you have to light up all the edges. Okay. You have to do what? You have to light up all edges, all edges, right? By choosing the minimum number of nodes. So how will you do that, right? So if I have to select something, right? So see, guys, if you have to understand one thing here, right? You have to understand one thing here. Let us say that if I'm talking about natural scenario, right? So let's say if this particular node is there, okay, and this particular node is there. So can I say one thing, guys? Can I say one thing, that if, like, see, if you will see, so 2 is having, like, you can see that 2 is having an edge with 1 and 2 is having an edge with 4. Okay. And you have to what, you have to be greedy. Okay, you have to think in a greedy fashion. Now see, if you will light up this 4, okay, if you will light up this 4, then this whole edge will get lightened up. Please give me a +1, or write 4 in the chat. You can write 4 in the chat. Are you getting my point? Let us say, you have to think in a greedy fashion. So let us say, normally, if you will light up this node 4, like, okay, if you will select this node 4, then this whole edge will get lightened up. Okay, so please write 4 in the chat first of all. If you will select this node 4, then this whole edge between 2 and 4, this will get lightened up. Correct? Okay, this is what is going to happen. But is it a good, like, is it optimal for you? Because in that case, again, you might have to choose one, and then that is how this edge will get lightened up. Okay, or you have to select two, right? You have to select, either you have to select this guy, then this edge will get lightened up. But like, because there is another edge between 1 and 2, it should also get lightened up. Is that clear? So but instead of this, if instead of choosing 4, if you choose to, if you choose 2, okay, then what will happen, it will have an effect right here. Okay, and it will have an effect here also. So that is how you will choose the minimum number of nodes. Does it make some sense that, okay, I should not choose the leaf node? Okay, I should not choose the leaf node. Please give me a +1. Is everyone clear with this idea, that you should choose this guy? If you choose this guy, then automatically this node also gets lightened, this edge also gets lightened up, and this edge also gets lightened up. Is that clear? Okay, so please write 2 in the chat. Okay, so basically I have chosen, which nodes I have chosen? I have chosen this node 2. Is that clear? So I've chosen this node 2. Is that clear to everyone? So I've chosen this node 2. Okay, so if we choose this node 2, then in that case this gets lightened up. Now if you will see here, so let's say if I choose this node 6, right? So if I choose this node 6, then what will happen? This edge will get lightened up, right? Then after that, again I might have to choose. So let's say if I'll choose this, then this and this will get lightened up. So do I want to choose 2 nodes from here, that is 3 and 6? No. Instead of that, there is a better approach, because see, I will never choose the leaf node, because if I will choose this node, then this edge will get lightened up. But after that, I have to choose this node also, then this and this edge will also get lightened up. That is how the whole tree will get lightened up, all of the edges. So in this case, instead of doing that, if I will just choose this node, okay, then this edge is also going to get lightened up, this edge is going to get lightened up, and this edge is going to get lightened up, right? Because 3 is having edges with all these other nodes, right? So in that case, I might choose 3, and in this way the whole tree will get lightened up. Okay, so by choosing 2 edges, like by choosing 2 nodes, total 2 nodes, right, the count of the nodes is 2. By choosing 2 nodes, the whole tree gets lightened up. Is it clear? Please give me a +1 if everyone is clear, right? If everyone is clear till now, please give me a +1 and hit the like button as well. Okay, hit the like button as well if you are clear till this point. If everyone is clear till this point, you can hit the like button and give me a +1. But hitting a like button is mandatory. Okay, so this means that we should choose nodes that have children or, okay, so I'll tell you. See, basically, if you will observe, like if you will observe here, right? So can I say one thing, that if I'll think in this greedy fashion, right, if I'll think in this greedy fashion, so there's one thing very sure, right? So there's one thing very sure, that I have to traverse this tree first of all, right? Now, in, like, apart from traversing this tree, I have to think of one more criteria. Now what is that criteria that I should think about? Like, if my child is not, okay, understand this thing, uh, if you are having this kind of a node, let's say, if I'm drawing something like this, let's say if you are having this kind of an edge, okay, so let us for a second assume that, okay, this guy is the parent, okay, and let's say this guy is the child, okay. So do you all agree with me, okay, do you all agree with me that, let us say that if my if I will not choose my child, okay, if I will not pick up my child, then I have to pick up myself in order to have this edge highlighted. Is that clear? Please give me a +1, guys. If everyone is clear with this idea, please give me a +1. Is that clear to everyone? That in this case, if I have to consider one thing, that if I will not select my child, in that case I have to select myself. Please give me a plus one if everyone is clear. In order to have this edge highlighted, let us say that if my child is already chosen, okay, if my child is chosen, then I don't need to choose myself, right? Because see, if let's say that my child is automatically chosen, right, let's say my child is chosen, in that case I don't have to light myself up, because if my child is chosen, then in that case this edge is already lightened up and I don't have to choose myself, right? But if my child, like, because see, if this kind of a scenario is there, let's say that if I expand this, right, so let's say if I don't choose this guy, right, if you will see, let's say if I don't choose this guy, then in that case, in order to have this edge highlighted, in order to have this edge lightened up, I have to choose this guy, right, I have to choose this guy. So in that case I'll choose this guy, right? Now after that, if you will move up, right, if you will move up, if you will move to this guy, now since its child has been chosen, right, its child has been, so for this node is already chosen, right? As you can see in this diagram, for this particular node, this node is already chosen, right? So in that case you don't have to choose it. Is that clear? Is that clear to everyone? Please give me a plus one. This idea is clear, that if, see, if you will see here, very frankly, if you will see here, so let us say that I talk about things normally, right? So see, if this guy, like, see, for the leaf node, I will never, see, if I'm at a leaf node, then I will never select them. For this leaf node, does it have a child? No, so it will never be selected. Okay, a leaf node will never be selected. Please write never in the chat or no in the chat. Okay, please write no in the chat, guys. A leaf node is never going to get selected. First things first, that a leaf node is never going to get selected. You can give me a plus one, you can write no in the chat and everything, and then I'll proceed further only. If you are getting this idea, you can hit the like button as well. Okay, a leaf node is never going to get selected by me. Okay, because see, as I told you, if you will observe, if I will select this leaf node, then this will get highlighted, but in that case I have to choose this also, then this will get highlighted. But instead of that, if I will not choose the leaf, if I will choose this node, then this will get highlighted as well as this. So in that case, I will be choosing lesser number of nodes, right? Does it make some sense, guys? So similarly, I am saying that, okay, when I'll be at this leaf node, so it does not have any child, right? So in that case, I will not choose this guy. Okay, I'll not choose this guy. After that, now if this is the child, okay, and this is the parent, so if I want this edge between this parent and this child to be highlighted, okay, if I want this edge between this parent and this child to be highlighted, can I say that I have to select the parent? Please write yes in the chat or plus one in the chat. I have to select this parent, right? I have to select this guy. Does it make some sense? Please write yes in the chat. I have to select this guy. Does it make some sense? Please write plus one in the chat if you are clear, right? If my child is not chosen, right, I think we need to choose the middle node. No, basically, see, in normal terms, what you will think about is, like, you will think that, okay, if, like, I am at the leaf node, if I'm at the last node, so it does not have any child, so obviously I will not choose it. That's it. Okay, then if you are at this guy, right, so now this is the child and this is the parent, you will see, like, if you move back in backtracking, okay, so now if your child is not chosen, then you have, so in order to have this edge highlighted, I have to choose either of the nodes. And if my child is not chosen, then I have to choose this node. Please give me a plus one. Agree with me? Please write par in the chat. In this case, I have to choose this parent. Please write PAR in the chat. In that case, I have to choose this parent in order to have this edge highlighted. Okay, in order to have this edge lightened up. Is that clear? Now, similarly, if you will see further, if you will see moving further, so let's say if I have my child, okay, well, like if this is the child, okay, and this is the parent now. So if you will see here, now if this parent, if this child has been chosen, so this means that this edge is highlighted, because this node and this node, these two nodes are there and this edge is there. So if the child is chosen, so then this particular node is highlighted, it is lightened up. So if it is lightened up, right, if it is lightened up, in that case I don't need to choose the parent, right? Because if my child has been chosen, right, see, if as you can see that this child was chosen, in order to lighten this up, my child was chosen. So now if this node has been chosen, so do I need to choose this parent? Because if for this node, if its child has been chosen, do I need to choose the parent? No. Please write no in the chat. So no, I don't need to choose it. Is that clear to everyone, guys? Does it make some sense? Please tell me, is it clear to everyone till now? Is the idea clear to everyone? Please give me a plus one. If my child is not chosen, then in that case I have to select the parent. Is that clear? Is that clear? That if child is not chosen, right, if child is not chosen, in that case I have to choose the parent. Choose parent. Okay, in that case I have to choose the parent. Okay, but else if the child is chosen, then don't choose the parent. That's it. Is that clear? That is the main idea about this. If you are clear till this point, so please make sure to hit the like button, guys. Please make sure to hit the like button if you are clear till this point. Is it clear till now? Please give me a plus one. Please give me some feedbacks and responses in the chat. if till now everything is clear to all of you, right? Does it make some sense till now? I hope it does make a lot of sense till now, right? Then I'll be proceeding further as well. Okay, and I will never be choosing the leaf node. Okay, because see, the leaf node will not have any children, right? So initially I will, for every node I'll mark it as not selected. Okay, initially for every node I'll mark it as not selected, and for this leaf node, for this guy, I will run the DFS down. So obviously it does not have any children, right? So since it does not have any children, so that is why for its children things will never be checked. Okay, so the leaf node will never be chosen, because if you choose leaf nodes, then in that case you will be choosing more number of nodes. So in order to be greedy, you will never choose the leaf node. So please write never in the chat, or no in the chat. Okay, please write never in the chat. You will never choose the leaf node. Okay, you will never choose the leaf node, because see, the leaf node does not have any child. Initially every node will not be selected. Okay, initially no node will be selected, so this node is also not selected. Now if you look at this node's child, so it does not have any child. So in that case you don't have any information about the child, because it does not have any child, so it will still not be selected, right? But when you are at this guy, so you will see that okay, this guy's child has not been selected. So in that case, you, this is also initially not selected, but when you will look at the child, so you will see that okay, its child is not selected. So in order to lighten this edge up, you have to choose this guy. Okay, this point is clear to everyone? If you are clear till this point, please hit the like button, because this is the basic condition, right? This is the basic approach. So please hit the like button if you are clear till this point, and give me a +1 as a feedback that okay, you are clear with the things, and then I'll proceed further with a little bit of code as well. Okay, now in this, what you have been given is, you have been given this format of edges. Okay, in this the input has been given like this. Okay, what you have been given is, you have been given edge 1 comma 2, right? You have been given edge 2 comma 4, you have been given edge 1 comma 3, right? You have been given the edge 3 comma 5, you have been given the edge 3 comma 6, right? These are the things that you have been given. Now if these are the, like, this is the edges that you have been given, right? So can I say that I have to build the tree? So basically I have to build the adjacency list. So please write adjacency in the chat, ADJ in the chat, right? I have to build the adjacency list. Okay, for iterating, for traversal, for traversal of this tree, I have to build the adjacency list. Is that clear? Please write ADJ in the chat if you are clear with this thing. That okay, from this given information, I have to build the adjacency list. Is that clear? Please give me a +1 and write ADJ in the chat if everyone is clear with this idea. That I have been given the information about the edges, but obviously for iterating through this tree, I need the adjacency list. Is that clear to everyone, guys? I hope it makes a lot of sense for everyone, right? Okay, so initially what I will do is, I'll build this adjacency list, right? So what I will do here is, let's quickly move here. So what I'll be doing here is, first of all, I'll be building the adjacency list for myself. So basically there are nodes from one based indexing. So that is why I'll be building a adjacency list of size n+1, because the indexing is one based. Okay, so you can write 1 in the chat. The nodes are like 1, 2, 3 and up till n. So if I want to store, like, if I want to store the nodes 1, 2, 3 up till n, so in that case, the adjacency list size should also be n+1, right? So in that case, I'll declare this vector int, right, adjacency, and I'll have it as n+1, right? Now after this part is done, I also need a visited array. So initially let's not draw it. Okay, so what I will do is, now I'll iterate through all the edges. So int I starts from 0, I is lesser than edges dot size, right? Now then after that I'll do I plus plus, right? So I'm iterating through all the edges, right? So basically initially what I'll do is, I'll say that okay, the node u is what? U is edge of I0, like edges of I0, and similarly v is what? V is equal to edges of I1, right? So after this I'll build the adjacency list. So I'll say that okay, adjacency of u dot pushback, right? Pushback nothing but v. Let's push back v. Okay, basically it's a bi-directional thing, right? Because this is not a directed graph. So as you can see, if 1 comma 2 is there, so I'm storing this as u and this as v. Now in the adjacency list of 1 I'm having 2, and in the adjacency list of 2 I'm having 1, right? So does it make some sense? Please write +1. If you are clear with this, please write ADJ in the chat, just for some clarification, that okay, you are clear with this thing, that we are going to build this adjacency list. Does it make some sense, guys? Please write yes in the chat. Basically I'm building this adjacency list. I'm assuming that you must be knowing this much basic part, right? Is it clear, or should I explain? You can write ADJ in the chat if everyone is clear with this adjacency list building thing, right? Once I have built this adjacency list, then I will traverse this graph, right? So please write DFS in the chat. Okay, I'll be using a DFS traversal for iterating through this particular tree. Okay, so I'll be using the DFS traversal. Before that, if I'm traversing, so I need to have a visited array. So please write VIS in the chat. I need to have a visited array that will tell me that okay, If a particular node is visited, then don't visit it again. Is that clear? So initially I'll mark everybody as not visited. Is that clear? Please write VIS in the chat, everyone. Okay, please quickly comment on VIS in the chat if everyone is clear with this idea, that I'll be having a visited array before applying a DFS traversal on this particular tree. I will be doing what? I'll be having a visited array so that I don't visit the nodes again and again. Otherwise, I might get a time limit exceeded. Okay, then I will start the DFS traversal. Okay, and from where will I start? So initially, you can say that the root node is nothing but one. Okay, initially the root node is nothing but one. Okay, that is the root of the tree. Okay, after this what I will do is I'll pass this adjacency list. Okay, I'll pass this visited array as well, and then I will have a counter as well. Okay, initially obviously the counter will be 0. Okay, so initially what I will do is initially I'll say that okay, the count is equal to 0. Please write 0 in the chat, everyone. Initially the number of nodes that I have chosen will be equal to 0. Okay, and I'll be passing this counter as well, and after this DFS traversal is over, so in the end, I'll return this count of the nodes that I have selected. That will be the minimum number of nodes that I'll be selecting. Is that clear to everyone? Please give me a +1 if you are clear till this point, and then obviously I'll move further. Right? Is this point clear to everyone? If you are clear and if you have not liked the video as well, so you can feel free to like the video. Okay. So initially the counter is going to be 0 as well. Now after that, I'll start with my DFS traversal from here on. Right. So what I'll do is I'll have the int DFS. Now in this case, I will have the int current node. Okay, I'll have the int current node, and from this current node, first of all, vector int adjacency is what I'll be having first of all, and I'll be also passing the vector int visited array, right? So ampersand visited array is what I'm passing. Now after this, what I will do here is I'll also pass the count, so int ampersand count, so that any changes that I make to the count, they are finally reflected. That is why I'm passing it by reference here. Okay, now after this, what I will do is when I visit a particular node, right? So when I visit a particular current node, so I'll mark it as 1. Okay, I'll mark it as visited. Is there any cycle in the tree? No. Basically in tree normally there is no cycle. Okay, in tree there is no cycle, but you don't want to repeat. Okay, since you have built this bi-directional adjacency list, so you don't want to repeat again and again, right? So as see, when you are at this node, let's say you are at 2. Okay, so when you are at 2, then from 2, let's say you go to 4, then you find that okay, in the adjacency list of 4, 2 is also there, so then you might go up, whereas actually 2 is already visited, so you don't want to do those things again. So that is why we are taking a visited array. Okay, so it is a ritual that we should normally take visited array. Then why we need, because we have built a bi-directional array now, so bi-directional adjacency list. So this is a undirected array now, the undirected graph. See, if I'm at this node, then from here I'll go to this, and then 4 will tell that okay, 2 is also there, then from 2 you will go here. So from 2 you will call for this node 2, but that should not be done now, because once you have already called from 2 to 4, then you should not call again, otherwise there will be a cycle. Is that clear? Then from here you will call again for 4, right? Then from here it will call here. Are you getting? That is why you will be in a cycle. Does it make some sense? That when you see, if you don't take visited array, then from 2 in the adjacency list of 2, 4 is there, so 2 will call for this guy. Then in the adjacency list of 4, 2 is there, so this will call, then this will call, then this will call. So you might get stuck inside a cycle. So that is why you will take a visited array kind of thing for security. So once you visit a particular node, then you will mark it as visited. So please give me a +1 if everyone is clear. Once you visit a particular node, then you're gonna mark it as visited. Okay, now after this, what I will do is I will take a bool variable. Okay, so this will be of bool type. Okay, this DFS call will be of bool type. Why? Because it will tell me, please give me a +1 if you are clear. It will tell me that okay, whether this particular guy has been chosen or not chosen. Ultimately it will tell me this thing. That is why I'll have it as bool. Okay, so initially, that is why the return type will be bool. It will tell me that okay, whether this guy has been chosen or not. So please write bool in the chat. Okay, if it returns false, so this means that that particular node has not been chosen. If it returns true, so this means that the current node will be chosen. Okay, is that clear? Please give me a +1 if everyone is clear with this bool idea as well. And if you are new, then you can hit the like button as well. I can see number of people watching are more compared to the number of likes, so let's maintain the equality there. Okay, now what I will do is I'll say that okay, selected. Okay, let's initially say that selected. Okay, current is not selected, so initially I'll mark it as false. Okay, initially I'll say that okay, the current guy is not selected. Okay, initially I'll say that okay, I have not selected the current guy. Okay, now after that, what I'll do is I'll iterate through the adjacency list. Okay, I'll iterate through the adjacency list of the current node. So I'll iterate through all the children. So auto child is to adjacency of current. So basically what I'm saying here is I'm iterating through the adjacency list of the current node. Okay, and if my child is not already visited, okay, if the visited of the child, okay, if it's equal to 0, okay. If my child is not visited, okay, if my child is not visited, then after that I'll call the DFS for my child. Is that clear? So initially I will mark myself as not selected, okay. Initially, like if I have to write it, so I'll write current selected, okay, current selected as false. Initially the current node is not selected, and then I'm iterating through the adjacency list of the current node, and I'm iterating through its children one by one, okay. Now when I'm iterating through its children one by one, so I'll see that, okay, if a particular child for the current node in its adjacency list has not been visited, in that case I'll call the DFS for that, okay. And I'll call, like, I'll pass the child as the current node, okay. I'll pass the adjacency list, I'll pass the visited array as well, okay, and I'll pass the counter here as well, right? This is what I will be doing. And when I'm doing this, so it will obviously return something. Now it will return something. This DFS function, as you can see, it has been made as the bool type. So my child will return something. Now my child will return true or false. Please give me +1 in the chat if you're clear. That when I'm calling the DFS for my child, when I'm calling the DFS function, if my child is not visited, if for the current node, its child is not visited, then I'll call the DFS function for the child. And when I call the DFS function for the child, then the DFS function for the child will also return something in terms of bool value, okay. So we need to mark true first. Basically whenever I'm visiting, then I'm marking as true. So I don't think that you need to do it. If you want to do it like that, then what you can do is you can initially say here that visited of 1, let's say, is equal to 1. You can say that, okay. In that case, if you want to do it like that, so in that case, when you can do it like this, okay. This is also fine, right? So initially I'm marking 1 as visited, then for anybody that I'll be calling, I'll mark it as visited. This is also something that you can do, okay. Naikaj, I hope that you are okay with it. Now when my child is returning something, so let's say bool, okay. Now my child will be returning a bool value, so it will tell me that, okay, is child selected, okay. So is child selected, right? This is the thing. Is that clear? So I am having a, like, this DFS call will tell me that whether my child is selected or not, okay. Now if it happens, right, understanding this thing, guys, right, see, if is child, okay, if child selected, is child selected is equal to false, right? So this means that if this is false, right, so this means that if child is not selected, okay, if child is not selected, right, if child is not selected, then in that case what will I do? Can anyone tell me? If the child is not selected, in that case what will you do? If for a current node its child is not selected, then can I say that I have to select myself? I have to select the current node. If for the current nodes its child is not selected, then I have to select like itself, it. If for the current node, if it's, see, if you will see here, so for a particular node, right, let us say that its child has not been chosen. In that case, in order to light this up, in order to light this edge up, you have to choose the current node, okay. If for the current node its child has not been chosen, in that case you have to choose the child, okay. Are you getting my point? Are you getting my point? Is that clear? Please give me a +1, guys, if you're clear with this idea. So please give me a +1. Don't be so much silent in the chat if you're clear with this thing, and hit the like button if you're watching new. Okay, please give me a +1 if my child is not chosen, right? So that is what I'm getting in return. This DFS call that I'm doing for the child, it is returning that whether my child is selected or not, okay. So it is returning me true false. If my child is not selected, guys, right, so if is child selected is equal to false, if my child is not selected, right, if child is not selected, in that case I have to choose myself, because if my child is not selected, so I have to select at least for a particular, for these two nodes, in order to highlight this edge up, I have to choose either of the nodes. So if the child is not chosen, then I have to select this current node, right? Makes sense, everyone? Right. So in that case, I'll say that, okay, current selected, okay. I'll mark the current selected as true. Is that clear? Please write true in the chat, everyone. In that case, I will choose the current node, okay. Otherwise, let's say that if my child was chosen, so let's say scenario was something like this, okay. Let's say if I will draw something like this, let's say if it was something like this, then this, and then this, okay. So let's say this guy was not chosen. Now let's say this is the child, okay, and this guy is chosen, right? Let's say this guy is chosen. So let's make a big tick. Let's say that, okay, this guy is chosen. Now if this is the current node, so if my child is chosen, do I need to choose myself? Obviously not. Obviously not. Are you getting my point? Are you getting my point? Right, in this case I don't need to choose. But let's say that, let's see, if you have to understand one more thing, that let's say there was some edge like this also, right? Now if this guy, if let's say this is also another child, okay, now if this is not chosen, right, if this is not chosen, then can I say that I have to choose this node in that case? Yes or no? Please write yes in the chat. Are you getting my point? That there are two children for this current node. If you will see, so I will check that, okay, is this child chosen? Yes, this child is chosen. So in that case, I will think that, okay, I will still say that, okay, everything is fine. But when I call for the other child, okay, when I call for this second child, right, and it is, let's say it is, you can see that it is not chosen because leaf will never be chosen. So in that case, if this guy is not chosen, right, so in that case, I have to choose this. Is that clear? Please give me a plus one, guys. Is it clear to everyone? These kind of cases are also clear. You can give me a plus one if you are clear with this, right? So that is why I'm having this, right? So for every child, I'll check if any of my child is not chosen, right? If any of my child is not chosen, so let us say that if the diagram, I will expand something like this. Now this is another child, right? So let's say if this is chosen, in this case, let's say this child is also chosen, right? Now let's say after that I expand the diagram here, and this particular guy has not been chosen. So if I check, okay, this child is chosen, so fine, I will not choose myself. This child, child one is chosen, child two is also chosen, so that's fine. But when I'll come to this child three, right, so it is not chosen. When I come to the every child, so I come to this child as well, now it is not chosen, so I have to choose myself. Is it clear? Please give me a plus one and hit the like button. That is what I'm expecting. The minimum that I'm expecting from you is nothing but hitting the like button if you're clear, and giving me a plus one flawlessly. Is that clear? Is that clear to everyone till now? Okay, it can also be solved using the highest degree of the node. There can be various ways. I do not disagree to this, but no worries, right? So after this loop is over, okay, after I have gone through all the children, right? So see, as I'm saying, after I have checked for this child, okay, this child, okay, so that will ultimately that will help me to decide whether the current is selected or not. Okay, that will help me to decide that whether the current node is selected or not. Okay, so in that case, I will check after the loop is over. Okay, please write over in the chat. After the loop is over, in that case, what I will do is I'll say that, okay, after the loop is over, so is the current guy selected or not? Okay, SELE CTD. After that, I'll check that if the current guy is selected or not. If the current guy is selected, in that case, I'll say that, okay, there is one more node that is selected, and I'll do a count plus plus. Is that clear? Please write plus plus in the chat, count plus plus. Sir, your method, you discussed that method also. I might not have that much time. Already we are 30 minutes into the stream. So it will take a lot of time, and then people will not watch if the video is very long. So I have to discuss only one approach. Okay, so if the current selected is like if the current selected, if the current guy is selected, okay, so in that case I have to do a count plus plus. If this current guy that I was, for which I was doing the DFS, if it is selected, then I have to increase the number of people that are chosen. Please give me a C plus plus or I plus count plus plus in the chat. Is it clear to everyone, guys? This point is also clear to everyone. Please tell me. Okay, this point is also clear. This point is also clear. Okay, now after that, what will I return? So in the end, I have to return that, okay, whether I was chosen or not. So I will return this bool variable only, no? That whether I was chosen or not. So selected to my father, I will always return that whether this current guy was selected or not. Is that clear? Till now, everyone is clear with this. I hope that it makes a lot of sense to everyone. Is it clear, guys? I hope that I have not made any mistakes. Let's see how it goes further. Okay, so okay, I need to remove the comments, right? So let's remove this comment and let's try and compile it. Okay, it works on the samples. I think it works. I hope it should work on the all the other test cases. Let's see. If it does not work, then I'll check that also. But let's see what happens. Okay. So this problem gets accepted. So please write ACOP in the chat. There is nothing less than ACOP that I'm expecting in the chat. Okay. Please write ACOP if you are clear, or you can write AC in the chat as well. Please write AC or ACOP in the chat. Okay. If you're clear with this till now, then I can repeat something if you have some doubts, or I can go through the code again. But please write ACOP in the chat. Okay. If you're clear till this point, that is what I'm expecting as minimum from you. If you're clear till this point, so please give me a plus one. Write ACOP in the chat as well. Okay. I'll open the IDE so that I can share this code link with all of you as well. Okay. So do you think that this problem was that much difficult? Do you think that this problem was that much difficult? Personally, if you will ask me, so I'll say that, okay, it was not that difficult. Please write easy in the chat. Please write easy in the chat. Don't you think that this problem was easy? Don't you think that this problem was easy? Guys, it's written as hard, but please write easy in the chat. That is what minimum I expect from you. Please write easy in the chat. This problem was very easy for all of us. Right? We have been doing it for so long. It's very easy for us. It's not that difficult. Right? Could you dry run this DFS? I think I might run out of time. Okay, so you are saying that, okay, what will happen for the leaf node? Okay, I'll explain that also. So let us assume that, okay, I have been given some tree like this. Let's say this is one. Okay, let's say this is two. let's say this is 3. Okay, let's say this is something like 4. Let me draw it using some other color, right? So what about, like, the question will be, okay, that what about the leaf? What about the leaf? How are we going to take that forward? So see, what I will do is, let's say if you draw this kind of a test case for yourself. Okay, now if you mark this value as 1, this is 2, let's say this is 3, this is 4. Okay, so what you will do, from here you will call for this guy. Okay, now from here you will call for this guy, right? Now when you call for this guy, right, so initially I'll say that, okay, 4 is not selected. Okay, initially, because for everybody initially it is false now. Initially 4 will not be selected. Please write false in the chat. Everyone agrees? Initially 4 is not selected. Initially any node is not selected. Are you getting? Initially any node is not selected, right? Initially every node is false. Initially every node is nothing but false, right? Initially no node is selected. So this guy calls for this child, this guy calls for this child. Okay, now for this guy, okay, for this node, you will call for its children. Does it have, like, see, now for 4, what you will do is, for 4 you will call in its adjacency list. Okay, so 1 is already visited, 2 is already visited, right? So is there anybody in the adjacency list of 4? Please write no in the chat. There is nobody in the adjacency list of 4. Okay, so in that case this loop will never run. Are you getting my point? In this case, in the adjacency list of this leaf node 4, there is nobody that is not in the adjacency list of 4. Basically what will happen, in the adjacency list of 4, nobody is there who is unvisited. Okay, everybody is visited in the adjacency list of 4. Since it is a leaf node, so everybody above it must be already visited. Okay, so in that case this loop, like, it will never call a DFS for anybody, so still its current selected, this variable will be false for it in the end. So this counter will not increase for it, and you will return not selected for it. Okay, so you will return on the upper part, what you will return is, you will return a false. So this guy is going to return that, okay, I am false, I am not selected, right? When you return a false, right, when you return a false, then the panic button is pressed for the parent. Now this is the current guy. Now for this guy, its child says that, okay, I'm not selected. In that case it has to select itself, right? So in that case, this guy will be marked as true. Okay, this guy will be selected, so the count will now become 1, right? The count will now become 1. And similarly what will happen here is, now for this guy, this returns a true. So in that case, 1 is not selected still, that's fine. But now 1 will call for this child as well. Now when one calls for this child, so initially this is not selected, 3 is not selected. Now is there anybody in the adjacency list of 3? Please write no in the chat. 3 is a leaf node. Okay, 3 is a leaf node, so there is nobody that is unvisited. Okay, everybody is visited, since 3 is a leaf node. So in that case, it does not have anybody in its adjacency list that is not visited. All the people in the adjacency list of 3 are visited, right? So in such a case, what will happen, you can see here that it is marked as false. So initially 3 will be marked that, okay, 3 is not selected, it will be marked as false. Then when I will run through the adjacency list of 3, so there will be nobody who is unvisited, because everybody will be visited. So I'll never go to this if. Then this loop will end, and it is not selected, so the counter will not increase. And in that case, what I will do is, I'll return this variable as well. Okay, so in that case, this guy will return that, okay, I am not selected. Okay, this guy is not selected, right? When this guy is not selected, so in that case, what will happen, the father, this current guy, will have a panic button, right? So now this current guy 1 will press the panic button, and it has to select itself. So it will be marked as true, that, okay, this guy is selected. And when this is done, so in that case, the counter will increase by 1 more, and the counter will increase to 2. Now if you have to see how many people are selected, so when 2 is selected, okay, when you select this guy 2, then indirectly you lighten up this edge, okay, and you light up this edge. And when you select this node 1, right, when you and after that, if you'll observe, when you select this node 1, then you lighten up this edge as well, so the whole tree gets lightened up. Please give me a +1 or clear OP in the chat, or understood in the chat, if you are clear with this idea. Is everyone clear with this idea? I hope that everyone is clear with this idea. I have shared this code link as well in the chat. So is everyone clear? If you are clear till this point and you enjoyed this video as well, so guys, please make sure to hit the like button if you understood everything. Okay, and make sure to give me a +1 after this video is over. Also make sure to subscribe this channel if you haven't already. Okay, so I hope that everyone enjoyed this problem overall. I also enjoyed this. Initially, I also thought that okay, this might be a harder problem for us. But if you understood, so make sure that after the video is over, if you understood everything, the smooth explanation, so please make sure that after the video is over, go to the comment section of the video and please write easy in the chat, +1 in the chat, understood in the chat. Okay, whatever is your feedback. Thanks a lot for joining. I'll see you in another live. Till then, good night. Take care. But before that, Please make sure to hit the like button and give me a +1 as well. And I have given the code link in the description. Make sure to code it out by yourself as well if you haven't. Till then, good night, take care, all the best, and keep coding, keep solving problem of the day every day without any delay. It might be hard, it might be easy, but make sure to keep your practice. Whenever the recession will go off, then you will have a lot of opportunities. Till then, thank you, and I'll see you in another problem of the day on Wednesday. Good night, everyone.